All right, so if I take a look at 18, 18 says I have 5D minus 8D minus 4 is less than or equal to negative 4 plus 3D. Is this the one you're talking about? Awesome. Okay. Well, the first thing, Maggie, what I'm going to do is I'm always going to do adding the opposite because I feel like that clears up a lot of misconceptions or misunderstandings about what we have. So I'm going to go ahead and do adding the opposite on both of that, on all of that subtraction. I just have 2 of them. So on the left side, I am going to combine my like terms. I always want you simplifying each side of the equation or inequality before you start working from side to side. So I have 5D plus a negative 8D is going to give me a negative 3D plus negative 4 is less than or equal to negative 4 plus 3D. Now for those of you that are like, these are exactly the same, I'm going to just not finish the work. Can't do that. All right. From here, I need to get all my variable terms onto one side, all my constants onto the other. So I'm going to add a 3D to both sides. So I end up with negative 4 is less than or equal to negative 4 plus 6D. Now I'm going to add a positive 4 to both sides. So I have 6D is on my right. I have 0 is on my left. All right, so I have 6D is greater than or equal to 0. I need to get rid of that multiplication by 6. It's positive, so I don't flip it. This is where we look to see if our coefficient is positive or negative. Is at that point when we have a one-step inequality. Or my 6's divide out, so I end up with 0 is less than or equal to D, or D is greater than or equal to 0. Maggie, does that help you? Awesome. Carmen, what could I do for you, sweetie? 35. All right. So if I take a look at number 35, 35, they give us the shape. You guys, I do want you using rulers, please. That kind of, again, is like a no-brainer for me. All right, so here's my triangle. They tell us it's a right triangle. So my height is 8 centimeters. My base is x plus 1 centimeters. And they tell us that the area is less than or equal to 44 centimeters squared. Okay, so this is the maximum the area can be. This A is our actual. How do I find the area of a triangle? How do I find the area of a triangle? Lily? Yep, 1/2 base times height. So I'm going to go ahead and put that in. I have to see that somewhere. So I'm going to go ahead and put that in. So I have 1/2 times my base, which is x plus 1, times my height, which is 8, is less than or equal to 44. All right, so now what I'm going to do is I can multiply these in any order that I want. So Carmen, are you good with that? Are you good with where I am right now? Excellent. Okay. So now I can multiply, if this is 1/2 times x plus the quantity of x plus 1 times 8. All right, I can do 1/2 times 8 first. How many of you guys recognize that I can do that first? So I'm going to do that because I can divide out common factors. So what I'm really left with is 4 times the quantity of x plus 1 is less than or equal to 44. And then from here, I have the distributive property. So I have 4x plus 4 is less than or equal to 44, and then I'm just going to finish solving. So I have x is less than or equal to 10 centimeters. Are you cool with that? Awesome. What else can I do from the homework, Joseph? 40. All right, let's take a look at 40. All right, so 40 said a gym is offering a trial membership for 3 months. So we have gym membership, and it's for 3 months. By discounting the regular rate by $50. Shh. Ladies, we're going to discount regular rate by $50. So $50 is not the regular rate. It's not the discounted rate. That's what says by discounting the regular rate by $50. Okay. You consider joining the gym if the total cost of the trial, so we want the total cost of trial to be less than $100. Okay. Which of the inequalities can you use to find the possible regular monthly rates? Now, for those of you that did no work for this, shame on you. You still have to do this the regular way. You still have to write a game plan. You still have to write the inequality. All right, that's lazy. You know I'm not taking lazy. All right, so if I was to write this as a game plan, I have my cost per month times my number of months is going to be, well, it has to be less than, it doesn't say or equal to, it just says less than my total to spend. So Joseph, are you good with that? Okay. I don't know my monthly rate. And this is this is just the monthly rate that I'm going to pay. This actually has to be written as an expression. This has to be my regular rate minus the discount rate times my number of months. So if I was to simplify that or make that more detailed, Joseph, that's what I would write. So there is my regular rate of X. All right, so I would have the quantity of X minus 50 times 3 is less than or equal to 100. And then I would solve that. Does that help you? All right, you have to write game plans for this, you guys. Okay, so are there any other questions? All right, so tell me, part of what you did was no solution in infinite solutions, correct? All right, so somebody tell me, how do I know if a solution is no solution with an inequality? So if you can't think of it off the top of your heads, go back into your notes. How do I know when I'm done with a solution if it's no solution? Ashley? Well, that is... Yes, that's not what I'm asking. When we get done solving a problem, what would this solution have to look like for me to say this is a no solution? What does this solution have to look like for you to be like, oh, that's no solution? Molly?
In this one, the number you substitute would be less than 0.
No. What does a solution have to look like? I'm not saying how do you check if something is a no solution. I'm not saying how do you know if a number is not a solution to it. I'm saying, which is what you should have done in your notes. So go back in your notes from Friday. This is one of the things. This is from example 4A and 4B. How do you know by looking at a solution? Go back into your notes right now. This is example 4A and B. What does your solution, when you're done, what does your solution look like for you to be like, oh, that's no solution? Ryan? Be more specific. Give me. I agree, but what does that mean? So give me an example of what one might look like. Negative 4 is greater than negative 2. Is negative 4 greater than negative 2? Nope, so that's false. I agree with you. That's a no solution. What does an infinite or all real number solution? I think they say identity. What does an identity look like? Joseph, give me an example. Negative 1 is greater than negative 6. That is true, right? So tell me something about the solution for a infinite or identity. I always call it infinite solutions. Different books say different things. Identity, all real numbers, infinite solutions, that all means the same thing. That means any number is a solution. All right? No solution means there is no number. That makes it true, so it's a no solution. What do you notice in your solution, the solution that it looks like, what do you notice is the same for infinite solutions and for no solution? What do you notice is the same? Rita? No, there's not always a zero. You can have a zero, but it's not always a zero. Lily? They're always both numbers. The variable's gone. How many of you guys notice the variable is gone in a no solution, and the variable is gone in an infinite solutions, or identity? All right, that is not a coincidence. That is simply what they are. Because if the variable is still there, like we have here, d is greater than or equal to 0, that means we do have a very finite amount. We do have a limit to what our answer can be. All right? We don't have all real numbers and we don't have nothing. There is a solution set to this, and it's everything less than 0 here, including 0. All right, that's something to remember when we look at infinite solutions and infinite solutions and no solution. All right, that variable goes away completely. Does that make sense? All right, I think we're good to go. You guys keep going. You guys, I'm late, so go ahead and put your books in your locker and just grab your lunch, please. It is chilly out, so bring as many layers